Hello, let's imagine a scenario based on a problem statement for creating an invention. Suppose we want to press this gel bottle by building a mechanism that allows us to press the gel bottle without touching it. Of course, this would fall into the category of devices that use electrical power, like a motor or something similar. There are many different ways to approach this, as you may have seen. Let's say we start with this problem, and when we try to press it, by chance. As for the leftover materials we happen to have these two items. They're actually automatic perfume sprayers, the kind you might have seen before. Inside, they use two batteries and have an internal mechanism. You put a scented cartridge inside, and there's a light sensor. If someone comes close, the sensor detects it and triggers the mechanism to spray the perfume. But the reason I chose this item is because most of the time, people who use it tend to forget to replace the batteries, since it requires two AA batteries. When the batteries go bad and are left inside, they deteriorate and cause rust to form in the mechanism. Usually the mechanism itself might not be affected, but the battery compartment, which has 4 springs. Have you ever seen it? The battery holder has 4 springs, and the rails or connectors that complete the circuit often get damaged. So I thought it would be worth taking apart. This one still works. I tried taking it apart to show you, which wasn't difficult at all. The casing is already deteriorated, especially the mechanism itself, which isn't very clear to see, but you can still somewhat make it out. There's a part on top here that can be pressed down by the force from the 2 batteries, which then powers the motor. There's also a certain experimental device inside which makes its movement very slow, but it still has enough force to be useful for our purposes, as I've mentioned before. We use the mechanism from an air freshener spray head. They use this mechanism because they use the force from it first, and then it passes through the experimental set, and in this part it can move. At the tip it just moves up and down, that's all. Originally, the idea was to press the air freshener can, similar to a spray can, to release a short burst. But for our purposes, we use it in the same way. We use its position to pull, but we don't pull directly on our gel solution bottle. We don't pull directly. Instead, we connect it through a lever. There's a lever piece that connects between this position and the bottle. The idea is to have it pull down. It will pull the mechanism of the plunger on the gel spray bottle down using this method. With this we can add a bit more leverage because we use a lever as the connector. Given our requirements, if we were to use the air freshener directly, attaching it to the bottle, the method would probably be quite difficult to implement. So, with this setup, it's clear that we have another lever connecting between. There's a lever on the pivot point, and then it extends past the length of the solution bottle, reaching the mechanism itself. Every time it pulls down, the solution is dispensed once. So, this meets our requirements by using a geared motor inside here. Next, from the mechanism of the air freshener sprayer, it passes through a gooseneck piece to pull down and press our gel bottle. As mentioned earlier, we use the mechanism of the air freshener sprayer, or adapted, because this mechanism uses a path. First, then, it passes through the test motor section, and in this part, it can move. At the tip, it simply moves up and down. Originally, you had to press the air freshener can, similar to a spray can, to release a short burst. For our design, we use the same principle. We use its position to pull, but we don't pull directly on our gel solution bottle. We don't pull directly, but instead, we connect through. There is a lever that connects this position to the bottle. It pulls downward, engaging the mechanism on the gel spray cylinder as a connector. The reason for this is that if we were to use the air freshener directly attaching it to the bottle, it would be difficult to operate. So, with this setup, you can clearly see that we have another lever connecting between. There is a lever on the pivot point that extends past the bottle of solution, reaching the acid mechanism. Every time it is pulled down, the solution is dispensed once. This meets our requirement by using the force applied here. Next, the mechanism of the air freshener spray passes through a lever to pull down and press our gel dispenser. I'll show you a close-up image so you can see exactly what we're talking about, the source of the force. As I mentioned earlier, I use 2 horns. They are connected so that the motor pulls. Look here, you can see the lever, right? The lever will tilt down as when you use the hot switch, the lever will go down and then come back up. The distance here, as you can see, and the way the lever is connected is to make things more convenient. This is a third-class lever, where the effort is applied close to the fulcrum, and the resistance is farther from the fulcrum. So it requires more force than the method we used before, but it's for convenience. As I mentioned earlier, this method It will press down on the bottle at the same spot every time. I'll demonstrate this for you. You'll notice there's a constant sound. This is the sound of the sensor. When we 291 times. Because it will release. German. Because everyone can see it, right? Every time it will be. Now let's talk about the code for this part. Here we're using the KidBright board. As you probably already know, the KidBright board has an LDR, or what we call a light sensor, built right onto the board. So what we've done in this case is we've added a new LED, as you can see here. This is an LED that we've just installed, and we've also used a plastic sleeve. You can use a drinking straw, preferably a darker colored one, to prevent the light from leaking out and staying on. So the light will only shine straight out the front, and for the other plastic sleeve or another piece of straw, we use it to cover the LDR. This way you can see that if you're worried about your hand blocking the light will reflect. Watch closely. The LDR here will detect the light reflected from my hand, and then it will trigger the mechanism to activate once. This is how it works. So even if you're worried about your hand blocking the light, in reality it's not actually blocking it. It's just reflecting the light, and any object that reflects light will have the same effect. Watch as I move my hand to demonstrate. You'll see what I mean. As soon as it detects something, it will send a signal. If there's no object in front of it, the LED light that's emitted won't be reflected back to the LDR, right? But if there is an object in front of it, the light will be reflected into the area. Actually, if the object is white or has a surface that reflects easily, it will work even better. That's basically how it operates. So, when the reflected light hits the LDR, it will signal the board to switch and activate the motor for one cycle, and then it will return to a standby state like this. I think you can picture it now. We use the KidBright board without any external sensors at all. Just the LDR on the board is enough for it to work. For output, we only use a single output. In this case, Pi uses only the output net, and we use the 5-volt power from the board, connecting a capacitor to the LED to share the power from the KidBright board. So, in this system, you could even use a power bank, and it would still work the same. I think you can visualize it now. We have the KidBright board here. There's also a geared motor that's been taken out from unused equipment. Actually, you can take it from a toy or anything that has a DC motor, 3 volts, 6 volts, whatever you have. It's up to you. Just make sure it has enough power. You'll need to experiment, because with motors, every time the speed decreases, the torque increases. So in this case, you'll find that the distance for the gel bottle requires a fair amount of force, but it can still be pressed. That means a motor with just 3 volts, using 2 AA batteries as the base, can still operate effectively. Like this. So, we'll have one power supply set. That is, we'll use 2 AA batteries to power the motor. As for the circuit board, we're thinking of using power from a power bank, or even using 3 batteries will still work just fine. Normally, this base here, which I didn't mention at the beginning, the base or the plate we use to mount everything is actually a laser disc. Many people probably haven't seen one before. Right here, if you look closely, you'll still see the letters NGM. This is from the movie Goodbye Pearl. Back in the day, movies like this. The ones with good quality were made from laser discs, or you'll notice that the discs are quite large, about 12 inches in diameter. Nowadays, these are almost never used anymore, because if you want to watch a movie, modern DVDs are clearer, even though they're smaller. Honestly, I should have kept some, but I didn't. Now you can see that leftover materials can be used for many different things, and it also helps promote the skill of combining scientific knowledge with coding to create projects like the one you've seen. Thank you for following along from the beginning until now. If you have any questions, feel free to ask. You are welcome to reach out anytime. It would be my pleasure. Goodbye.